All right, for today, my job is to teach you about decomposition. It's not just for dead bodies anymore. You're going to get to do it today. Ooh, that's kind of sounds a little scary. You're going to decompose a function. Well, what does it mean to compose a function? That means where you take one function and you mix it with another one. It's kind of like Rice Krispie bars. You take, you get your Rice Krispies on the one side, and then you got your marshmallow on the other, and then you put them together, and then you got something different. That's like f of x plus g of x. And when you do that, you get something, and its domain, it depends on what f of x and g of x were, right? So let's go back to the very beginning and say, if I wanted to add f of x plus g of x, then I need to know what f of x was, right? So let's say that f of x is 3x plus 7, and g of x is the square root of x minus 2. Now, one of those has got a domain that's pretty easy to find. The other one, I'm going to give you a domain. Domain of f. I'm going to give you an artificial domain and say, I want x to be less than negative 3. Less than or equal to negative 3. Then would you figure out what f of x plus g of x is? And then would you figure out the domain of f of x plus g of x? That's the easiest kind, where you just mix those two domains together. I like to think of it as two number lines on top of each other. All right, let's pause for a second while you try that one. Okay, this should have been pretty easy. You just take this function and you add it to this function. So it's 3x plus 7 plus square root of x minus 2. And you can't combine those. Even if you were trying to multiply them, which we aren't, but if we were, you couldn't put them together. All right. Now, some people noticed on the homework last night that there were some times where there were things that were being added together. Like, for instance, 1 over x plus 1. If I tried to add this and this, I could add them together if I could get a common denominator. All right. So I know this is a little bit off topic, but I know that you need to know this. So I'm going to take a moment and make sure you know how to add these two. Just think of this as a new problem, completely different. It's not the same question. But would you just try to add these two? It reminded me that you guys need to know how to find common denominators. Hint, you're going to multiply this side by something to make it so they have a common denominator. Is that what you guys did? X plus 1, x plus 1? If you're not familiar with this concept, you want to multiply by 1. That's really equal to 1. But you multiply by 1 in a creative way that allows these to have a common denominator. Now the denominators are the same, so they can be added together. You have to be careful with distributing this, because this is a FOIL kind of problem. And then the 7x and the 3x can be combined, and the 8, 7, and the 1 can be combined. So this will be 10x, and that'll be an 8. Raise your hand if you got that one right. Good. I needed to remind you to be fair to you so that if you ever see that again, you'll know how to get common denominators. Okay, so now we're going to go back and just talk about domain of the original problem that I gave you in the first place. So if you go back to that slide or wherever you kept it in your notes. All right, the domain of this guy is going to just be the domain of f, which was, here's negative 3. And the domain of g, and I'm going to put them right on top of each other so that I can see where they overlap well. And domain of g, x minus 2 greater than or equal to 0, x greater than or equal to 2. So here's 2. And I fill in that in, and it's greater than or equal. And where do those two overlap? They don't, so there's no solution. So you can add these functions together, but you can't put anything in for x. Isn't that weird? Now you'd have thought that you would, because we had something look like a normal function, but this right here is what's messing it up. You can't use any negative numbers. Because why? Because they told us that. They gave us that domain. Okay? Do you get how nothing overlapped here, and therefore I can't, I mean, it doesn't work there, it doesn't work here, it doesn't work here. There's no place that it works. So there's no solution. All right, what did you get introduced to yesterday? Yesterday you got introduced to the idea that if you have two functions and you have one function eat the other function, a function inside of a function, then the domain can be found with this kind of tricky formula. I'm going to give you a problem that we'll try for that. F of x is equal to 2x minus 9, and we'll make g of x a different color. We'll just keep it simple, 1 over x plus 2. And now, this one I'm going to give a domain given x has to be greater than or equal to negative 5. My question is, if the f function eats the g function, what's the answer and what's its domain? We pre-calc teachers were emailing back and forth, and one of them said, can we just have like 10 more days on that? Because a lot of kids had trouble with this. So don't feel bad if you have trouble with this and that formula is confusing you. You wouldn't be alone. That's why that teacher was teasing about how we need a lot more time before we test on that stuff. And I want to get you started on the formula, and I'm going to say it wrong, but it'll be something like domain of P intersected with P of X in domain of Q. That's not right, but that's just to remind you. You need that formula to remind you how to get the domain of the composition. Again, I wrote it wrong on purpose because I want you to try to jog your memory on how to do that. Okay, I'm going to pause for a second. See if you can get not only the composed function. Notice not decomposed, but composed function. And its domain using that formula. All right, so I'm going to make the f function eat the g function. So I start by writing the f function with a big empty stomach where the x was, because he's going to eat a big dinner. And that's his big dinner right there. So he eats one of those. Now, did I say you had to get a common denominator to add them together? No. If you did, that's awesome, but you didn't have to. Okay? If you did, you would have been thinking like this. What can make a common denominator? Oh, if I make this have an x plus 2 on it. And then I could make it have a common denominator of x plus 2. And then the top would be this distributes. So there's a negative 2 to cancel the positive 2. So all that's left is 9x. There it is. It's pretty clean and nice. But you didn't have to do that. I'm curious, how many people did do that? All right, so in the context of having just done that the problem before, I thought you might have, but I didn't say you had to. On the test, you're going to have to. Okay, so just so you know, you need to know how to find common denominators. All right, it's not that hard. I just put the 1 underneath the 9, and then I said, what's the denominator? Multiply by that on the top and the bottom. Okay, so now, what's the domain? The domain is, here's the formula, check your paper for this. It needs to have domain of the inside one, which is g, intersected with g of x in the domain of the other one. Raise your hand if you had the right formula. Okay, that's almost everybody. If you didn't have it, I'm going to make it bigger here. You need to copy that down. Notice that this and this go together, but they're not the same thing. One's a domain, one's the function. Why did I start with this one? Because it was the inside function. Yes? Okay, hold on. You are correct. There is a negative in this one. I apologize. All right. Sorry, my brain was already on to the domain thing here. So now I'm going to try to take this formula and stick in all the pieces I know. Do I know domain of G? Yep. Domain of G is this one, and that's a really easy one. Everything except -2. So I like to do a number line for that. Can't be -2. Otherwise, it's everything. Remember, domain is not what you can't put in, it's what you can put in. Everything except -2. Okay, now intersected with g of x. Do I have that? Sure, this is g of x in domain of f. That goes in here. And I have 1 over x plus 2 is greater than or equal to -5. Okay, now, I know this is a tricky one. And I told you last time, do you remember last time I said you can't multiply on both sides by x plus 2? Or maybe I didn't tell you about that last time. Did you know that you're not supposed to do this? And I get the idea. It would cancel this, and it seems really slick. Do you know why you can't multiply both sides by x plus 2? I'm hearing crickets, so I'm assuming you do not know why you can't do that. I'm going to back up for just a second then and show you something and see if this makes sense. If I had 2n is greater than 8, do you get I can divide both sides by 2? Okay. Why can't I divide both sides or multiply both sides by n? Because if I multiply both sides by n, you might think, I don't even know why you'd want to do that. But can I even do that? I can't do that. Because it says greater than. Do you get I might, when I'm multiplying by a variable, I might be multiplying by a negative number? Or at least I allow for that possibility? Do you know that multiplying by a negative number would make that reverse, go the other way? Okay, that's why you can't multiply both sides of an inequality by a variable. All right, so that's probably why you guys were taking so long, is you were stuck on this, right? Okay, yes?
Would it also be -16 in the equation?
Okay, I missed. Are you talking about up in this thing?
Yeah, the -1.
Okay. All right, I will double check that. You're right. Doggone it. I wish I could go back and re-record this thing, but I can't because this is my last hour. She caught that I should have distributed this -9 to both parts, and I didn't. I tried to do it quick in my head. You're right. There's a mistake in that. All right. I will finish it up here. I hate to keep going back and forth, but and you're right. It'd be great if you could catch me at the same time as you caught me about the negative. So I'm going to multiply that out. -9x, -18. Yup, I should have taken the time to actually multiply it out. Now I combine it with this 2. And now that 2 goes with the -18 and makes it -16. And so now I got -9x minus 16 all over x plus 2. And all right, so that was just a quick reminder that you can get a common denominator and add them together. You may recall that I said I didn't say you had to, so this would have been a good enough answer. That reminds me of how in calculus they tell people, don't simplify it if you don't have to, because you might mess it up. That's what I did. I simplified it and I didn't have to, and I messed it up. All right, obviously we have a visitor here. I'm going to pause for a second while we...
No, I'm learning.
Okay, so, sorry, that got really distracting, but you're right. I'm glad you caught me because it's on tape, so I'd like to fix it. Back to this thing. We were trying to figure out what would take this and make it a number line like this. What numbers would work, right? Okay. Do you get that the key moment is when this thing equals -5? I'd like you to think about that for a second. Because then it would be or equal to, right? So what could make 1 over x plus 2 equal to -5? That's the question. Remember, it's got an or equals, doesn't it? So then you solve for that. Now on this kind, you can multiply both sides by a variable, and so I'm going to multiply both sides by x plus 2. What? Didn't you just say a second ago that, no, that was if you have a less than or a greater than sign. You can't multiply both sides by a variable. So I just cheated, took out the or equal to, and we'll test to figure out where we should be. All right, so I just multiplied both sides by the denominator. That's a theme from the top 20. You're supposed to know, oh yeah, of course I would multiply by the denominator. And then you get 1 equals, and I'm going to multiply this out this time, not try to do it all in my head, -5x minus 10. Going to add 10 to both sides. 10 plus 1 is 11 equals -5x. Divide by -5. X equals -11/5. Woo! So then I go back in here, and I needed a number line. Here's my number line. And I'm going to say, here's -11/5. And that would make it equal to -5, so it works. Now the question is, should I shade to the right or should I shade to the left? I'm going to give you this task. You know that 0 would be to the right of this, right? Stick 0 in and then see if it works or not. We're doing something called testing intervals. Put in the 0. You get 1/2 is greater than -5. Is that true? Definitely. So then I should shade to the right. Now I got to overlap this one and this one to get my final answer. So I'm going to just redraw the one I just did. Where's -11/5? It's like on this side of -2 is all that really matters. Okay, and since I said that it was or equal to, this is filled in. And since I said that it had to be numbers that were bigger than that here, I'm going to shade to the right. And then your final answer is between -11/5 and -2. And then from -2 to infinity. Okay, that one was nasty. If I made them that nasty on the test, only 3 kids would probably get it right. So let's do a more tame one. More like R2-ish or R3-ish one. Okay? All right. Hopefully, that was the one meant to stretch you. This is the one meant to bring your confidence back. Like, you can actually do this. Okay? Let's see if this works. F of x, g of x, and let's make this square root of let's give this one of those kind that is given to you, a domain that you don't get to pick. We'll say that the domain of f is that x has to be greater than -4. Now, this one, not so nasty, but we've talked through how to make the formula, We've talked through how to get common denominators. We've talked through all those nasty things that can happen, and most of those nasty things aren't going to happen this time. So, give this one a shot. Find out what is f of g of x and what's its domain. Pause for a second while you give this one a try. Okay, here we go. So let's say I want to find f of g of x. I'm going to write the f function, and that's this, and I'm going to write it with a big empty stomach, and he's eating a g. So that goes in here. Square root of 2x minus 1. This is particularly easy one because you can't simplify it. Some kids think you can distribute the 3 into that. You cannot. Okay, so this one's done. Okay, now how about its domain? I always started with dg, the inside one, intersected with the inside one, except not the domain, it's the actual function, in df. So then dg, I never figured that out yet, I'll go do it now. 2x minus 1 needs to stay greater than or equal to 0. So then 2x greater than or equal to 1, x greater than or equal to 1/2. So here's dg, here's 1/2, greater than or equal to. Now g of x, that's this one, goes into this one. And I hope this one was easier for you to solve. I know it wasn't a no-brainer, but square root of 2x minus 1 needs to be greater than or equal, or greater than -4. All right, and I want you to just pause for a moment and say, when would a square root come out bigger than a negative? Always. Wouldn't it? Is there any way for a square root to come out and be smaller than? No. Or equal to a negative? No. It would always be bigger than. So should we go on and do the normal things and square both sides? And then say 2x minus 1 is greater than 16. And then x has to be greater than 8? Nope. I bet a lot of you did. Is it true that x has to be bigger than 8? No, look back at the original. A square root will always be bigger than a negative. So that answer is all reals. And I get, well, that's a tricky one. And now I overlap these two. And it's from 1/2 bracket to infinity. How are you supposed to notice that? I'll warn you, there's 2 times that could happen. One, with square roots. Do you get square roots have to come out positive? What else has to come out positive? Wouldn't that always be true also? So absolute values and square roots. Keep an eye on those. Because those will always be bigger than negatives. They'll always be positive. Okay. So, if you did everything except you did it with the 8, you're pretty much on track. You just didn't notice that there was a tricky little twist in this one. That's why it's definitely an R3. Okay, so now, last thing I have to talk about is, what if I have a function of a function of a function? This would be comparable to a fish eats another fish and then is eaten by a bigger fish, which is eaten by a shark. You get all this whole bunch of functions devouring other functions going on here? And I've mentioned, I think, in the past, I wonder what the world record is for in one day having a little fish eaten by a bigger fish, 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 eaten by a shark. Probably, it just makes sense that it would have happened a whole lot of times with the ocean being as big as it is. 2/3 of the earth covered by water. All right, so anyway, let's get a typical question here, f of x equals 5x. But let's say x has to be greater than 1. And g of x is equal to square root of x plus 2. All right, so how am I supposed to start this? Always start where? Inside. So really, just break it down to one step at a time. All I really need to know is what's f of 3. So I stick a 3 in, and you get 15. Replace this with a 15. So now what are you doing? The inside, which is what? Say it. G of 15. Good. We're going to do G of 15. So I'm going to put a 15 here. And what is G of 15? Square root of 17. Now I should clean this up. It's f of the square root of 17. Now I stick the square root of 17 into the f function. And it's normally 5x. I'm putting an empty spot. And I'm going to drop in the square root of 17. 5 root 17. How many of you had that one right? Raise your hand if you did. Okay, excellent. 12-minute warning has happened. So I'm going to get us into our homework. And, oh, one more thing. And this is kind of like strange that it's just a side note, but it is this easy. I do need to talk about decomposition. So decomposition is kind of like I'm giving you a Jeopardy answer, and you tell me what the question must have been. This is two functions that have been made a composition of functions, as in f8g, and you got this. Then what was f? And what was g? It's like, what was the question? It's like when they say on, this is the largest of the planets. You'd say, what is Jupiter? You'd say, question, right? So what was the question here? F of x was x plus 2. Figure out what g of x would have to be so that when the f function eats it, you end up with this. I'm going to do a couple examples. Now it might feel hard. I'm telling you, in a minute, you're going to be like, oh my gosh, that's really easy. Okay. G of x would have to be, what would he have to eat and put in here to make that the same? Square root, he'd need to eat a square root of x plus 3. Raise your hand if you had that one right. Some of you noticed it already. Awesome. Here's another one. I'll make it blue. I don't know what f of x or g of x are, but I can tell you that g of f of x is equal to 1 over x minus 7 plus 4. When the g function ate the f function, you got this. Hint, figure out the f function first. The thing that was inside, that feels like it's an inside. So that was x minus 7. Now, what would g of x had to be to make that work? G of 1 over x plus 4. So you grab what would be considered the inside, you make that a function, and whatever this was, you replace it with an x. And that's the outside function. How many of you feel like you're catching on to this? All right, I'm at half. Let's do one more. F of g of x is 1 over the square root of x plus 2 plus 5. There's more than one right answer for this one. You may recall that I had suggested that you pull out the part you think was eaten, the inside function. I personally would pull out that, and I'd say that part got eaten. But there's more than one way. I'll show you, because I think some of you are like, but wait, I did it this other way and it works. You're right, another way works. If you do this combo, you'd say f of, and then this part has to be x, right? 1 over x plus 5. Did anybody have a different way that they did this one? Everybody did it that way? Okay. How many of you actually had the answer right? Raise your hand if you had that. Okay, good. Let me just show you, if you had wanted to do just the x plus 2 is an inside chunk, right? Couldn't that be the little function that got eaten? And so couldn't that be g of x? And then what would the other one be? I'm going to give you that question. If g of x is x plus 2, what would the other function have been? Square root of x plus 5. Raise your hand if you had that one right. Okay, cool. You get decomposition. That's it for that. All right, your homework for tonight. As with past challenges, I'm still learning how to use this Explain Everything app, and when I've tried to put the homework on at this point and like add it in, the video has quit on me. So I'm going to just pause this thing while I pull up the homework, and I'll tell what problems we are doing of the homework. Okay, so the first page of it is pink. This one's called 3.2 Day 2. And the first page is pink. Oh, you're really distracting me. Right in front of me. Come on now. At least I'm saving up for something new now. I already got a grappling hook on the way. All right, so anyway, number 25 you're doing, number 27 you're doing. Then number 31 and number 35. So far, only 5 of the questions, or no, 4 of the questions, sorry. That was 25, 27, 31, and 35. Then on the next page, 41, just 41. And on the next page, 44 and 45. Now on that bluish page that has the 44, 45, 47, 48, we're doing 44 and 45. I want to talk you through just one example. Look at the top function. It says the f function is defined by, you've never had your function given that way before, but it's not that scary. Watch and you'll catch on. What's f of negative 3? It's 4. What's f of 0? There it is. F of 0 is 1. What's f of 1? F of 1 is 3. To get how to evaluate the function, you just stick in the x of it. So if I said, what's the f of negative 2? You'd say it was 2. That's how you evaluate those functions. Those are good to make you think in a different way. All right, and that's all I have for you for the homework for today. And now